If you don't have a printer, you can just, like we've done before, just copy down the tables and write down the key information from the graphs. So the first section asks us to write a linear equation that represents the given information. Simple enough. You might need to look at this table from page 11 on how I'm doing these as a reference. So number one is a table, and on page 11, to find the slope, we have to figure out the change in y over the change in x. So how do you figure out the change? To go from -1 to 1, we add 2, because you would go -1, 0, +1. To go from 1 to 2, you add 1. To go from 2 to 3, you add 1. To go from -6 to -5, we go up 1. So it's a +1. There we go. To go from -5.5 to -5, you go up 0.5. So it's a +0.5. To go from -5 to -4.5, you go up another 0.5. So if you notice, this isn't the same number here as over here. So we need to actually take a look at our change in y over our change in x. How do we do that? Our change in y was 1. At the same time, our x added 2. And we would need that to equal all of the other changes. So we're adding 0.5, so it's 0.5 over 1. And then 0.5 over 1. If they all reduce, or if they're all the same number in the end, then it is linear. So is 1/2 the same thing as 0.5 over 1 and 0.5 over 1? The answer is yes, because 0.5 is really the fraction 1/2. So these are all the same. So that means that our slope is going to be 1/2. Now we need to find our y-intercept, because if we're trying to write an equation, y equals mx plus b. To find our y-intercept, we're looking for when there's 0 as x in the table. Well, from -1 to 1, 0 should be right in the middle here. So this is what I meant where we might have to follow our pattern. So our pattern is to add 0.5. So if we started at -0.6 and we had to add 0.5 to move one step, that would mean that our b value would be whatever -6.5 plus 0.5 is, which is -6. So b is -6. And take our slope, take our b value, and this equation is y equals 1/2 x minus 6. So I just did a table for you. I would pause the video and try number 2 all by yourself. Or at least see how far you can get all by yourself. Okay, same thing. We need to find our change in y over our change in x. So from 1 to 2, we add 1. From 2 to 3, we add 1. From 3 to 4, we add 1. From 3.75 to 4.5, we add 0.75. From 4.5 to 5.25, we add 0.75. From 5.25 to 6, we add 0.75. If you can't figure out what's being added to move forward, you could always subtract to go backwards. Like 6 minus 5.25 is 0.75. 5.25 minus 4.5 is 0.75. Change in y over change in x. So 0.75 over 1. 0.75 over 1. 0.75 over 1. These are all the same thing, which just gives us 0.75, but slope has to be a fraction. So what is 0.75 as a fraction? That means our slope is 3/4. So now we need to find our y-intercept. Our y-intercept is when x is 0 in the table. Well, x starts at 1, which means 0 would be up here. So we just follow the pattern but backwards. So if we added 1 to move down, we'd subtract 1 to move backwards to get to 0. If we added 0.75 to move down, we would subtract 0.75 to move backwards. So our b value is whatever 3.75 is minus 0.75, which is just 3. So we have our slope, we have our y-intercept, so y equals 3/4 x plus 3. Number 3 is a graph. It's fairly simple. I always start off on a graph by finding my y-intercept and then calculating my slope. Your y-intercept is wherever it crosses the y-axis, which is 2. We know this is a positive slope because it goes from bottom left to top right. And then you just have to figure out how it moves. So you just pick another point where it crosses at the corners of two whole numbers, and you figure out your rise over your run. We could go to this point right here, or we could count to that point, because right here it crosses at two whole numbers also. 1, 2, 3, 4, 5, 6 over 2. So I would get 6/2, which reduces to be 3. If you chose this other point to look at, you would go up 3, 2, 3 over 1, and you'd get the same thing anyways. That's all you have to do. So putting it together, y equals, our slope is 3x, our y-intercept is 2. Okay, number 4, we got to do a lot of stuff here. So this is those steps. First thing we have to do is find the slope. So slope is y2 minus y1 over x2 minus x1. So 0 minus 4 over negative 4 minus 4. That gives me negative 4 over negative 8, which is positive 1/2. So we know that our slope is positive 1/2. So we're going to take that slope and we have to plug it into y equals mx plus b. So where do we get the y and the x from? I just choose the first point every time. So instead of the y, we're going to put 4. Instead of the slope, the m, we already calculated that as 1/2. Instead of the x, it's the x value of your point, which is again 4, and we're trying to find b. And now we just do the math. So 4 equals 1/2 times 4 is 2. Subtract 2 from both sides, b equals 2. So we're taking this b equals 2, and we're taking this initial slope of 1/2, and we're putting it together. Y equals, our slope was 1/2, x, our y-intercept is 2, so plus 2. 5 through 8 asks us to find the intercepts in relative extrema for the given equations, right in slope-intercept form. So number 5 is in standard form. So you could do this two ways. You could put it in slope-intercept form first and then find your intercepts, or you could find your intercepts and then put it into slope-intercept form. I'm going to find my intercepts first. So I kind of make a table. So if I'm looking for an x-intercept, and then I'm looking for a y-intercept. So an x-intercept is when you take y and you plug in 0. A y-intercept is when you take x and you plug in 0. So I'm going to plug in 0 for y to find my x-intercept. So I have x minus 2. Instead of the y, we plug in 0 equals 8. And then you just do the math. So 2 times 0, well, that's 0, so it crosses out. So we just get x equals 8. So our x-intercept, or where that would cross the x-axis, would be way over here when x is 8. Y-intercept, we're going to plug 0 in for x. So we're going to have 0 minus 2y equals 8. Well, the 0 doesn't help us, so it just goes away. So we're left with negative 2y equals 8. And now we actually have to solve it. So to get the y by itself, we just divide both sides by negative 2, which means y equals negative 4. So on the graph, it would cross somewhere down here at negative 4. And then lastly, we want to get this into slope-intercept form, which is y equals mx plus b. So I'm just kind of adding on to my table. I like to keep my work fairly organized. So how do we do that? X minus 2y equals 8. In order to get it into slope-intercept form, you have to get y by itself. So to get y by itself, right now the y is stuck to this minus 2, to the negative 2. So the only thing we can do is subtract x from both sides. That would leave us with negative 2y equals, well, in slope-intercept form, the x goes first. So I'm going to write negative x plus 8. Still have to get that y by itself. It's being multiplied by negative 2. So I'm going to divide by negative 2 on both sides. So that cancels. I'm left with y equals, there's secretly a 1 here. So it's negative 1 divided by negative 2, which would make that a positive 1/2. The x doesn't change. And then 8 divided by negative 2 is a minus 4. And that's it. So number 6, I'm going to do the same way. I'm going to find my x-intercept first, then my y-intercept, and then put it into slope-intercept form. I suggest you pause the video so you can try number 6 all by yourself. Finding your x-intercept. That means into this equation, wherever y is, I'm going to plug in a 0. So I'm going to have 4 times x plus 0 equals 1. Well, plus 0 doesn't help me at all, so I'm just left with 4x equals 1. Divide by 4. That means that this would cross the x-axis when x equals 1/4. Sometimes they're going to be fractions or decimals, and that's fine. To find your y-intercept, you plug 0 in for x. So we would do 4 times 0 plus y equals 1. Well, 4 times 0 is 0. We're just left with y equals 1. Y equals mx plus b. So we have to take 4x plus y equals 1 and get the y all by itself. So the y just has a plus sign in front of it To move the 4x, we have to subtract it from both sides of the equal sign. This cancels. I'm left with y equals negative 4x plus 1. The y is all by itself, so we are done. Okay, number 7, we're only given 2 points. So in order to find our intercepts, we have to put this into slope-intercept form first. And it's going to be just how we did number 4. So if you wanted to try number 7, putting it into slope-intercept form by yourself, I already walked you through number 4, and it's the same thing that's on the back of page 11a. First thing we have to do is find the slope, which is y2 minus y1 over x2 minus x1. So 5 minus 1 over negative 4 minus negative 3. 5 minus 1 is 4. 4 minus negative 3, we keep change. So it's really negative 4 plus 3, which is 1. No, negative 1, sorry. Negative 4 plus 3 is negative 1. So 4 divided by negative 1 is a negative 4. So we're going to use a slope of negative 4 when we plug into y equals mx plus b. I always use the first point, just makes it easier for me. So y gets replaced with the y value of the first point, which is 1. M is your slope, which gets replaced with the slope you just found. X is the x value of your point, which is negative 3. And we are trying to find the b value. So negative 4 times negative 3 is a positive 12. Plus b isn't going to change. Minus 12 from both sides. B equals negative 11. So taking our b value of negative 11 and our m value, we can write our final answer. Y equals, our slope was negative 4, x, and our b value is negative 11. So that's putting it into slope-intercept form. Now we have to find our intercepts. So I'm just going to create a little table down here. If you need more room, you can always go on the back. So to find our x-intercept and then our y-intercept. Well, the y-intercept is easy. It's your b value. So it's negative 11. Your x-intercept into this equation you just found, you're going to plug 0 in for y, not x. So x-intercept, you plug 0 in for y. So 0 equals negative 4x minus 11. And now you have to solve for x. So x is glued to this negative 4. I'm going to add 11 to both sides. I'm left with 11 equals negative 4x. Divide by negative 4. Told you sometimes it's going to be a fraction. This would be a negative 11 fourths. And that's okay. So number 8 is the same process as number 7. If you wanted to pause the video and try it by yourself, or at least try to get started by yourself, you could do that. Okay, just like number 7, I've got to find the slope first. So negative 3 minus negative 5 over 1 minus 0. Negative 3 minus negative 5 really becomes plus or positive. Negative 3 plus 5 is 2. 1 minus 0 is 1. So this slope is just 2. So taking your slope, I'm going to take the first point and plug it into y equals mx plus b. So I'm going to take this first point. The y value is negative 5 equals our slope is 2. The x value is 0, and we're still trying to solve for b. Let's do some math. So 2 times 0 is 0. That just goes away. That leaves me with -5 equals b. So we're going to take our y-intercept and our slope and write an equation. Y equals, our slope is 2. Our y-intercept, or the b value, is a -5. So our equation is y equals 2x minus 5. Now we have to find our x-intercept and our y-intercept. Y-intercept is easy. It's your b value, so it's -5. Your x-intercept, you plug 0 in for y. So 0 equals 2x minus 5. We're going to solve for x, so we're going to add 5 to both sides, and we get 5 equals 2x, divide by 2, so x equals 5/2. And it is okay for your roots or your x-intercepts to be fractions. So make sure you have the front of page 12 all written down. It looks something like this. We are going to add to the back of it. Okay, flipping over, we need to discuss end behavior. So let's talk about end behavior. And we're going to talk about the equation from number 5, the equation from number 6, the equation from number 7, the equation from number 8, and then we're going to kind of make some predictions. Or generalizations. Okay, so number 5. If I asked you to sketch that graph, you would not need a set of x and y axes. A sketch, show me what it looks like. Well, it's a positive slope, so you know it's going to go like this. Perfect. If you can just sketch what it looks like, that's all you need to know to be able to state your end behaviors. So end behavior, as x goes to -infinity, y goes to blank, and as x goes to +infinity, where does your y go? So as x goes to -infinity, so if you follow your graph left, this arrow points down. You have to remember +infinity to the right, +infinity up, -infinity to the left, and -infinity down. And this is your y and your x. So if your arrow is pointing down, that means your y values are going towards -infinity. As x goes to +infinity, so if we follow our line up, your arrow is still pointing up, so that's also going towards +infinity. Number 6, y equals -4x plus 1. If I asked you to sketch that, what that would look like, it's a negative slope. It looks like this. That's all you need to know. So your end behavior, as x goes to -infinity, what happens to y? And as x goes to +infinity, what happens to y? If you follow your graph left, your arrow points up towards +infinity. If you follow your arrow right, or your line right, your arrow points down towards -infinity. So go ahead and give number 7 and number 8 a shot all by yourself. I would sketch the graph first, like I did up here, if you need a visual of it. Okay, so number 7, negative slope would look like this. X goes to negative infinity, so where does your left arrow point? Up towards positive infinity. As x goes to positive infinity, which way does your arrow point? That goes down towards negative infinity. Number 8 has a positive slope, looks like this. As x goes left, your arrow points down. As x goes right, your arrow points up. Okay, predictions, generalizations. So I wanted to just do a short summary of end behavior for any odd functions. An odd function means that the highest exponent is odd. And we've already talked about it. But I want to review it again because it's that important. So that would mean we'd have like x to the third, x to the fifth, x to the ninth, anything where the power is odd. So if you were to graph x cubed, and then x to the fifth power, and then I'm going to talk about x to the seventh power. X cubed means that it has the possibility of having 3 roots because of the power of 3. X to the fifth means that it could possibly cross the x-axis 5 times, and x to the seventh means that it would have 7 roots, whether they were real, imaginary, or anything like that. So x cubed, if you put x cubed in your calculator, it would look something like this if we had a positive a value, or it would look something like this if it had a negative a value. Here's what I want you to notice, is if I drew a line with a positive slope versus a line with a negative slope, the tails or the arrows point in the same direction. If we've got a positive slope, it's down and up. If we've got a positive a, it's down and up. If we have a negative slope, it's up and then down, and then up and then down if it has a negative a value. X to the fifth power would look something like this if it was positive. 1, 2, 3, 4, 5. If it had a positive a value, or 1, 2, 3, 4, 5 if it had a negative a value. Same thing. If you kind of rewrote it without all the squigglies, it looks like a line with a positive and a negative slope. So anything that has an odd power is going to have the tail ends that look like that of a line. So let's take a look and just take a guess on what the tail ends of x to the seventh would look like. So if we have a positive a value, we know that a line would look like this. So we would have this bottom arrow pointing down, and then some stuff would happen in between here, and then this arrow would point up. If it had a negative starting number, it would have a negative slope if it were a line, and it would have the starting and then some stuff, and then the arrow would point down. And that works the same thing even if we had x to the 277th. There would be all this craziness going on, but if it were a positive a, the tails or the arrows would still follow that if they were a line. And then that's what I'm just going to write here. I'm going to call them the tails or the arrows or the ends, whatever you prefer. Match for a line. And that's the big takeaway. So make sure on the back of page 12, you've got all this stuff written down.